Hello everyone. I hope you all been getting along well during this 3 weeks. Basically, we're going to have a total of 3 weeks off because of Hurricane Florence and the flooding afterwards. So I hope everybody's doing well. Classes are starting Monday, and when you come back on Monday, we're not going to have a lot of time to finish the material for exam 1. So we started section 2.3 lecture notes before the university closed because of the hurricane. So I am going to cover section 2.3 in a couple of videos. Some of this material is going to be reviewed because we already covered it in class. Right, the beginning material will be reviewed for many of you, and then we'll cover the remaining material, and you'll have everything you need to complete the My Math Lab homework and paper and pencil homework. And then section 2.4 I plan, and section 2.5 I plan to cover in class when classes resume on Monday and Tuesday, depending on what day your class meets, okay? So on the overhead, right, on the whiteboard, I have page 1 of section 2.3 notes, and the blank copy of these notes are posted on Moodle. And so the first thing that we're going to be talking about is the periodicity of the sine, cosine, cosecant, and secant functions. The trigonometric functions are periodic, and what that means is their values repeat every so often. So in the case of sine, cosine, cosecant, secant, they have a period of 360 degrees or 2 pi radians. And what that basically means is if I add 360 degrees to an angle, that doesn't change the value of the trigonometric function. So as an example, okay, you're familiar with the angle of 30 degrees. You know from the unit circle that the sine of 30 degrees is equal to 1/2. Well, because the sine function has a period of 360 degrees, if I add 360 degrees to 30 degrees, I get the angle 390 degrees, and the sine function doesn't change its value for that angle. The sine of 390 degrees is also equal to 1/2. So adding 360 degrees to an angle doesn't change the value of the sine function. And it's also true when I subtract 360 degrees from an angle. 30 minus 360 degrees is equal to minus 330 degrees. And so the sine of minus 330 degrees is also equal to 1/2. And so because sine, cosine, cosecant, secant, for all 4 of those trig functions, have a period of 360 degrees, adding 360 degrees to an angle or subtracting 360 degrees to an angle doesn't change the value of that trigonometric function. Okay. So on page 2, and so that's what page 1 and the top of page 2 are getting at in your lecture notes. So on top of page 2, we have some examples. And we're going to be working with radians in the first 2 examples and degrees in the last 2. So again, okay, sine, cosine, secant, and cosecant functions all have a period of 360 degrees, which is equal to 2 pi radians. So in the first example, we have the sine of 13 pi over 6 radians, right? That's more than one revolution. So on the side here, I only have one whiteboard to work with the video camera. So I'm going to do some writing down below here. 13 pi over, right? The sine of 13 pi over 6, okay? I can subtract 2 pi, which is equal to 360 degrees. I can subtract 2 pi from that angle, and it doesn't change the value of the sine function. So 13 pi over 6 minus 2 pi. Well, 2 pi is the same as 12 pi over 6. So we have 13 pi over 6 minus 12 pi over 6. And 13 pi over 6 minus 12 pi over 6 is equal to pi over 6. So subtracting 2 pi from this angle doesn't change the value of the sine function. So the sine of 13 pi over 6 has the same value as the sine of pi over 6 radians. And we know from the unit circle, the sine of pi over 6 is equal to 1/2. And so the sine of 13 pi over 6 is equal to 1/2. It has the same value as the sine of pi over 6. In the next example, we have the cosine of 33 pi over 4. And so this is more than one revolution. Okay, 33 pi over 4. In fact, it's more than 4 revolutions. Due to the periodicity of the cosine function having a period of 2 pi radians, we know that 33 pi over, the cosine of 33 pi over 4 has the same value as 33 pi over 4 minus 2 pi, okay, because it has a period of 2 pi radians. Well, we know that from previous example, 2 pi radians is the same as, I changed that. 2 pi is the same as 8 pi over 4. So we have 33 pi over 4 minus 8 pi over 4. And 8 pi over 4, 33 pi minus 8 pi over 4 is 25 pi over 4. So the sine or cosine of 33 pi over 4 and is the same as the cosine of 25 pi over 4. But 25 pi over 4 is greater than 1 revolution. So we got to subtract another 2 pi. And we got to subtract another 2 pi. So we have 25 pi over 4 minus 2 pi, which we can write as 8 pi over 4. And 25 pi minus 8 pi is equal to 17 pi. Well, 17, right? So the sine or the cosine of 33 pi over 4 has the same value as the cosine of 25 pi over 4, which has the same value of cosine 17 pi over 4. Well, that's more than 1 revolution. So if we subtract 2 pi from that, it doesn't change the value of the cosine function. So we have 17 pi over 4 minus 8 pi over 4, right, which is the same as 2 pi. 17 pi minus 8 pi is 9 pi, and so we have 9 pi over 4. So the cosine of 9 pi over 4 has the same value as the cosine of 17 pi over 4, which has the same value as the cosine of 25 pi over 4, which has the same value as cosine 33 pi over 4. But that's more than 1 revolution, 9 pi over 4. So if we subtract subtract 2 pi one more time, written as 8 pi over 4, 9 pi minus 8 pi is pi, 1 pi. So the cosine of pi over 4 is the same as the cosine of 9 pi over 4, same as cosine of 17 pi over 4, same as cosine of 25 pi over 4, which is the same as the cosine of 33 pi over 4. So the cosine of 33 pi over 4 has the same value as the cosine of pi over 4 after subtracting 4 revolutions. And we know that number is the square root of 2 over 2. That's what periodicity means. Okay? Every time I add or subtract 2 pi to an angle, it doesn't change the value of the trigonometric function. All right, now we're going to go to degrees. Secant of 420 degrees. You know 420 degrees is more than 1 revolution. So if I subtract 360 degrees from 420, I get 60. So the secant of 420 degrees has the same value as the secant of 60 degrees, because these two angles only differ by 360 degrees. Well, secant is the reciprocal of cosine, and the cosine of 60 degrees is 1/2, and the reciprocal of 1/2 is 2. So the secant of 420 degrees has the same value as the secant of 60 degrees, which is equal to 2. Cosecant 450 degrees. 450 degrees is more than 1 revolution. So I subtract 360 degrees from it, and I get 90 degrees. So the cosecant of 450 degrees has the same value as the cosecant of 90 degrees. Cosecant is the reciprocal sine. The sine of 90 degrees is 1. The reciprocal of 1 is 1. So cosecant 450 degrees has the same value of cosecant 90 degrees, which is equal to 1. Okay? So that's how periodicity works. Now, many of you I know are find working with degrees easier than radians. We could have converted these angles to degrees and solved these problems working with degrees, right? 13 pi over 6. To convert that to degrees, you multiply it 180 over pi. Pi's cancel. 6 goes 180 30 times. 30 times 13 is 390 degrees. So it might have been easier for some of you to write this as sine of 13 pi over 6 is equal to the sine of 390 degrees. And when you subtract 360, you get 30. And so then this is equal to sine of 30 degrees, which is 1/2. Okay. So you can always convert radians to degrees if you're more comfortable working in degrees. Okay. In the middle of page 2, we talk about the periodicity of the tangent and cotangent functions. And what that is telling us is that the tangent and the cotangent functions have a period of 180 degrees, or pi radians. The tangent and the cotangent function repeat their values every 180 degrees. Okay? So let's write up here that the period for the tangent cotangent function is 180 degrees, which is equal to pi radians. So this says, okay, if I add or subtract 180 degrees to any angle in degrees, it doesn't change the value of the tangent function or the cotangent function. Or similarly, right, for working in radians, if I add pi to any angle or subtract pi from any angle, it doesn't change the value of the tangent function or the cotangent function. So let's work the examples at the bottom of page 2 using the periodicity property, tangent and cotangent. So in the first exercise, we're going to find the tangent of minus 2 pi over 3 using the periodicity property for tangent. Okay? Well, tangent has a period of pi radians, so if I add pi to this angle, it doesn't change the value of pi. So I can add pi to that angle, minus 2 pi over 3, and it doesn't change the value of the tangent function. Well, minus 2 pi over 3 plus pi is equal to pi over 3. And the tangent of the angle pi over 3 radians is equal to square root of 3. So the tangent of minus 2 pi over 3 radians has the same value as the tangent of pi over 3 radians, which is equal to square root of 3. In the second example, okay, we have the tangent of 405 degrees. Well, I can subtract 180 from 405 degrees twice, okay, which is subtracting 180 degrees twice from 405 degrees is the same as subtracting 360 degrees. 405 minus 360 is 45 degrees. So the tangent of 405 degrees has the same value as the tangent of 45 degrees. And what's the tangent of 45 degrees? It's 1. And then lastly, we have the cotangent of 390 degrees. That's more than 1 revolution. So if I subtract 360 degrees from it, which is the same as subtracting 180 twice, I get 30 degrees. So the cotangent of 390 degrees has the same value as the cotangent of 30 degrees. And using your unit circle, okay, we know the value of cotangent 30 degrees is equal to square root of 3. So that's periodicity, okay? All 6 trig functions, okay, repeat their values every so often, okay? Cosine, sine, secant, cosecant repeat their values every 360 degrees. Tangent, cotangents more frequently. They repeat their values every 180 degrees, right? Which is the same as pi radians or 1/2 revolution. All right, so if you flip your page over to page 3, actually, class, I'm going to stop this video at this point, and then the next video will start at the top of page 3, okay? I don't want to make the videos too long.